So the next topic that we have is probability. Okay. Now you have the same concepts here that you've done in O levels as well. There's nothing much that's new here. So let's do it quickly as well. How is probability defined? Number of favorable outcomes divided by the total number of possible outcomes, right? Favorable means target outcomes, uh, the outcomes for which you want the probability, right? That's what you have in the numerator. In the denominator, you have the total number of possible outcomes. That's the formula that we will be using for probability. Now, when you're doing your calculations, just remember, whenever they say there are two things, and either the first thing happens or the second thing happens, what you do is you find probabilities for each one of them and add them up together because there's an or between them. Whenever there's an or between different cases, you find the probabilities for each one of them and add them together, right? When there's an and between the cases, you multiply them. Now the an example for adding could be that you're rolling a dice. What's the probability that you get a 3 or a 4? It's a six-sided die. What's the probability that you get a 3 or a 4? What's the number of favorable outcomes? Or let's do it separately as well, in fact. 3 or a 4, that means we can just find the probability of 3 and find the probability of 4 and add them up together. Probability of 3 is 1 over 6, probability of 4 is 1 over 6. You add them up together, you get 2 over 6. Okay? Whenever there's an or, you will be adding things together. Now, there's a condition for this that the events should be mutually exclusive, but that complication does not really come on the SAT. You'll study this in O levels what mutually exclusive events are. But on SAT, whenever you have something like this given, that two events, there's an or between them, you just find their individual probabilities and add them. Okay. If you have two things happening at the same time, or one after the other, you multiply their probabilities because now there's an and between the cases, right? The first thing happens and the second thing happens. You find the probability of the first thing, find the probability of the second thing, and multiply them together. Okay? So, for example, what's the probability of getting two heads when you toss two fair coins? Probability of getting a head on the first time you toss a coin, what would that be? 1 over 2. Probability of getting a head the second time you toss a coin, that's also 1 over 2. What's the probability of getting both of those two heads together? 1 over 2 multiplied by 1 over 2, that's 1 over 4. So when you have two things happening at the same time or one after the other, what do? You multiply those probabilities because यहाँ पे and होता है इन दोनों के दरम्यान में. ये clear है? Okay. Yeah, that's what you can remember. Whenever there's an or, you add probabilities. Whenever there's an and, you multiply probabilities. Okay. All right. Now, most questions that you get on the SAT on probability, they will involve some kind of a table. They will have information given in a table form, and you'll have to do calculations using that table. Okay. So let's have a look at this, for instance. Again, this is also mostly about doing some practice questions now. In terms of concepts, there's just a couple of things that we need to discuss, and then it's about practice. Let's do some questions on probability as well now. So you have a distribution and size, distribution of color and size of 450 shirts. You can see this table. If one of these shirts is selected at random, what's the probability of selecting a gray shirt? Now, in this particular table, they have given you the total for each row, they've given you the total for each column, and they've also given you the grand total, right? Sometimes they don't give you these totals. Whenever you have to do probability calculations, this is the first thing you should always do. If you have, for instance, just this part of the table given, you should always write down the totals yourself because that is what is going to help you do the probability calculations. Okay. All right. Okay. Now, if one of these shirts is selected at random, one of which shirts? One of these 450 shirts is selected at random. What's the probability of selecting a gray shirt? How many gray shirts do we have? 165. So 165 over 450, right? All of this information was basically irrelevant. That's too much information. They were just asking for this. 165 over 450. Is that okay? Acha. Let's have a look at this now. A car manufacturer produces cars in red, blue, white, and so on. The incomplete table shows the percentage of cars it produces in each color. If a car produces, what's the probability of selecting a red or silver car? Now, just a side point, probabilities are generally represented as a number between 0 and 1, right? 1 is the highest probability, which means whatever it is certain to happen. It will definitely happen. That's what 1 means. 0 means that that thing will never happen. Generally, probabilities are between 0 and 1. However, sometimes you will see probabilities written in percentage form as well, right? So 0 can be written as 0%, 1 can be written as 100%. So percentage की form में भी हो सकती है. Okay? Now, what's the probability of selecting a red or silver car? How do you find that? Can you complete the table first? The total percentage has to be 100%. 100 में से you just subtract all of these. What do you get? 20? 23%. Do this on a calculator. And then what's the probability of selecting a red or a silver car? You add those two numbers, 20% plus 23%, and that gives you 43%. And that's the result. Okay? All good? All right, let's move on. A box contains a total of 80 cookies. A cookie is to be selected at random from the box if the probability that a chocolate chip cookie will be selected is 0.45. How many chocolate chip cookies are in the box? Quickly. Yes? 36. 0.45 is the probability of getting a chocolate chip cookie. So you're given the probability in this case. And you have to find some missing number there. Since the total number is 80, 0.45 means 45% of them are chocolate chip cookies. So you just multiply 0.45 by 80, and that gives you 36, and that's the final answer. Is that okay? All right, let's move on. A fair die has 12 sides, each labeled with a number from 1 through 12. Die is the singular of dice. They sometimes use this as well. Dice भी कहते हैं, single dice को, और die भी कहते हैं. A fair die has 12 sides, each labeled with a number from 1 through 12, with a different number on each side. Two students each roll this die once. Okay. The first student rolls a 3. What's the probability of the second student also rolling a 3? So there are two people rolling a fair die each. The first student gets a 3. Now, first student gets a 3. What's the probability of the second student also getting a 3? 1 over? It's a dice that has 12 sides. D? What probability are we looking for? What's the probability that the second student rolls a 3? Yes? 1 over 144 multiply करेंगे? Multiply करेंगे? So you have two people. Both of them are rolling a dice. First ने roll किया, उसका 3 आ गया. अब दूसरे ने roll किया, what's the probability of that person getting a 3 as well? 1 over 12. Whatever happened to the first person, that is irrelevant. That's irrelevant, right? These two things are independent, right? Whatever the first person got, it doesn't matter. It does not affect the probability of the other. Is that okay? If they had asked you to find the probability of both students getting a 3, probability of both students getting a 3, then you would do 1 over 12 into 1 over 12. But they're not asking you for the probability of the first person. That's given, that's a 3. That does not affect what happens to the second person, so it's just 1 over 12 directly. Okay? All right. The table summarizes 190 scarves sold at a store by price and material. If a wool scarf is selected at random from the store, what's the probability? Okay, what's the probability that the scarf has a price of at least 81, at least $21 if a wool scarf is selected at random? Are we selecting a scarf out of these 190 scarves? Is that the total? Is the denominator going to be 190? It's not going to be 190. We are selecting a wool scarf. So we know the scarf that is chosen, it has to be out of these 75. So the denominator in this probability has to be 75. We are not choosing out of 190, we're choosing out of those 75 scarves. Is that okay? Now, out of those 75, what's the probability that the price is at least 21? What does that mean? It could be this, it could be this. Both of them are possible. What's the total number? 13 plus 44, that's 57. You say it's 57 over 75. Uh, 0.76? Okay. 0.76, that's the result that we get. Is that okay? So you have to be careful about the denominator. It's not always going to be the grand total. Sometimes it could be a row total or a column total as well. Okay, let's try another one. There are 8 jars of honey, M jars of mayonnaise, and P jars of peanut butter in a cupboard. If one of these jars is selected at random, which expression represents the probability of selecting either a jar of honey or a jar of peanut butter? One jar is selected randomly out of all of them. What's the total number of jars? H plus M plus P. So it has to be C or D, right? What's the numerator going to be? J plus, sorry, there's no J. H plus P. So it has to be C. Is that okay? So the total is the sum of all those three numbers, and then the probability that we're looking for is H or P. So that's H plus P. That's what you have in the numerator. Make sense? Yes? Okay. Let's try this now. The table shows the results of a survey in which students at 3 colleges were asked whether they live on campus or off campus. If one of the students surveyed is selected at random, which of the following probabilities has the greatest value? Okay, what are we? Which number are we selected from? One of the students surveyed is selected. What's the total number? 2,500. We're selecting out of all of those 2,500 people. Which of the following probabilities is the greatest? Okay, probability that the student lives off campus, given that the student attends college C. Now, what does that mean? This is a very important phrase that you need to understand. We will do this in A levels as well. It's called conditional probability. Conditional probability. But in this case, on SAT, you will get a much easier version of that. All you need to understand is whatever is given, that is going to be your denominator. What does it say? Probability that the student lives off campus, given that, so we know that the student attends college C. We know that the student attends college C. So it has to be one of these 870 people. Out of these, what's the probability that the student lives off campus? 596. This number is going to be 596 over 870. यहाँ तक we were selecting from 2,500. Yes. But now in the option there, they're saying given that the student attends college C, that means we know That person cannot be here. He or she has to be here in these 870 people. So the denominator, the total number of possible outcomes is now not 2500, it's 870. That's your denominator. Is that okay? Okay, now what about the rest of the options? Probability that the student lives on campus given that the student attends college C. Now in all of them, you can see it's given that the student attends college C. So the denominator for all of them, no, it's not the same. It's the same for the first two, not for the last two. So they've interchanged that a little. Okay. For the second one, it's 870 in the numerator, and the denominator you have 274. You don't need to evaluate these yet. Okay. Abhi sab likh lein, because you can easily compare some of them directly without using a calculator. So A is of course bigger than B, so B is not possible. You can just cancel that out. That's not the greatest number. What about C now? Given that the student lives off campus, what's the denominator now? Given that the student lives off campus, what's given is your denominator. Off campus, what's the total number of off campus students? 1055. This is the number that we are selecting from. Is that okay? 1055. That is your denominator. Okay. Out of these, what's the probability that the student attends college C? 596. 596 over 1055. Is that okay? And then, given that the student lives on campus, that's 1445. That's the denominator. That's a given. Out of these, what's the probability that the student attends college C? That's 274. These are all these probabilities. Which of them is the greatest? You can compare A and C if you want, but most likely it's going to be A. A is the greatest. Are these probability calculations clear? Because this is a very good example because you understand how to calculate all of these probabilities. So make sure that you understand how we are getting to these values. So whatever is given is what you have in the denominator. Okay. So in the first and second cases, we had 870 as the denominator because we were given that the student attends college C. In the second case, we were given that they live off campus, so that's 1055. And then given that they live on campus, that's 1445. Denominator has to be what is given. Is that okay? And the numerator would be that out of those numbers, how many satisfy the given condition? Okay? Let's move on. A new medical test is designed to give a positive indicator to a patient who has a certain virus and a negative indicator to a patient who does not. So you get a positive indicator who has, if someone has the virus, negative indicator if they do not have the virus. The table summarizes results for 1,000 patients who have taken this test. Based on the table, what's the probability that the test gives the wrong indicator, that the test result is false? When is the test result false or incorrect? It's either this, when they have the virus and the test says test gives a negative indicator, right? Or when they do not have the virus and the test is positive, right? So it's either 30 or 50. Out of what? 1000. So 30 plus 50 over 1000, that will be 80 over 100, which is 8%, and that's the result. Is that okay? No problems? Let's say somebody is testing for COVID. They don't have it, and the test result says The test result is positive. Is that a correct test result? No. Somebody has COVID and the test result turns out to be negative. Is that correct? No. So every test, every medical test that you have, it has a chance of giving a wrong result as well. Okay? टेबल में उसने आपको बताया हुआ है this is the actual situation. The person has virus or does not have the virus. And this is what the test is saying. Negative means the test is saying they don't have the virus. Positive means the test is saying they do have the virus. If they do have the virus and the test is positive, that's correct. If they do not have the virus and the test is negative, that's also correct. But the other way around will not be correct. If somebody has the virus and they get a negative result, that means the test is giving a wrong indicator. If they do not have the virus and the test is positive, again, that's a wrong indicator. So 30 plus 50 divided by 1000, that's 8%. Yes. Okay, let's move on. Let's have a look at this. The table summarizes the distribution of age and favorite sport for 150 members of a country club. One of these members will be selected at random. What's the probability of selecting a member whose favorite sport is tennis, given that the member is at least 45 years of age? That's given. So that has to be the denominator. Okay? What's the denominator now? At least 45 years of age. That's either this or this. So what's the total number of people out of which we are selecting? 100. 50 plus 50. We are selecting out of these 100 people. Is that okay? Now, what is it that we're looking for? Probability that their favorite sport is tennis. 14 plus 26, that's your numerator. That's 40 over 100, 0.4. Express your answer as a decimal or a fraction, yes, not as a percent. So that's 0.4.